Late last year, Meta released a transcription model that covers over 1,600 languages, and this is the best, if not the only option, if you're trying to transcribe some middle or low resource languages like Irish, or more obscure ones like even Manx. Now, if you speak English or many of the common languages, you have a great experience in AI. But of course, if you have a language that you want to speak or you do speak, where there's not much text or audio online, then the performance of models for transcription or LLMs is just not as good. And omnilingual ASR is quite beautiful in this regard. So I'll start off by giving a little demo here, and then I'll talk about the performance, some of the drawbacks, and some things you can do to improve transcription results in low resource languages. I'm on router.trelis.com. You need to log in and you can then go to OmniASR and try it out in the browser. I'll start off just with an English example here. And, it should be strong in English, of course, because it's a common language. Notice how you can specify the language with a little hint, say ENG, for example, or ENGLATN, if you want to use a Latin script to transcribe it. Some languages allow for transcription with different scripts. It's actually a free-form hint, so there is no strict typing when it's passed to the model technically. And you can see here if we listen to the audio.
Good afternoon. My name is Ronan McGovern, and this is going to be a talk from my YouTube channel.
So performance is quite good. First thing you'll notice is OmniASR does not punctuate or capitalize the language. And so this is a small drawback. If you did want to have the model punctuate or capitalize, you could use a punctuation model if it's English. Various degrees of performance doing that afterwards. You could run an LLM, but that kind of is a lot of weight if you've already just done a lightweight transcription. If you run another language, you're probably going to need to fine tune so that the punctuation and capitalization is restored. That's something we do for our clients. Typically, we would train a small punctuation model and then we would fine tune the model on some repunctuated text so that it performs better. Let me show you here an example in Irish. So this is me speaking a little bit of Irish. We'll transcribe. I'm going to let it auto-detect here as well. And we can listen while it's transcribing.
Ronan is anam dum, agus bemajig lauert, fui couple ruddy.
Okay, so yeah, you can see the performance here is actually really good. There are 0 mistakes here. I think maybe my grammar is a tiny bit off. But yeah, this is my name in Irish, Ronan Little Seal. And it's really good. It's really good. I will say the performance is not uniform. For example, I'll give another Irish example here. I think it's this one. And let's put in the hint, GLELATN. It should generally improve performance a little bit if you put in a language hint. And here we have...
Ronan is anam dum, Kunistatu and you.
So this part here is all correct. Anam dum, Kunistatu, how are you? And this part here is not. This is diagwit, this is... Agut is a different word. D is not a word. And then this should be run on instead of run on-ish, which I don't know what that means. So you can see the performance is not uniform. It's definitely Irish. I would say there's roughly hundreds of hours of data available. Hoping to make a video showing how to tune Irish soon. It's not super low like something like Manx or maybe more obscure languages. Manx in the same family actually as Irish. That's why I pick it. But broadly speaking, you're going to get some reasonable performance. You're just not going to be able to get the punctuation or the capitalization. Just in terms of the format you want returned, you can also choose different return formats. And of course, you can hit it with an API key so you can get transcripts if you like. And this model is currently hosted on Trelis Router. If you want to make use, there's a few free requests per month. Now, I'll make a few comments on the model itself. It's an amazing project, really. I was talking to one of the authors, Jean Maillard. I really appreciated the chat. A lot of authors, as you might expect, they literally went around to so many parts of the world to get 10 hours of audio on, I think they have 10 hours for all of these languages here. And because you've so many languages, the model is able to somewhat generalize as well between languages, which is a pretty beautiful property. Now, the model that I've showed you is the largest of the models. I'll show a suite here of the options. So you'll see that there is a range going from, let's see. Yes, so here you can see that there are 300 million parameter all the way up to 700 billion parameters. Now, these models were not trained with transformers or more conventional libraries, so they're a little bit more unusual to inference. You can inference them with transformers though, There's no VLLM support. So you need to figure out how to do efficient batching. There are actually CTC models. I'll briefly describe how those work. Those are much, much faster, even though the same size. But unfortunately, because they're not autoregressive, you can't put in a language hint for these models. So for that reason, they're not quite as good. Now you'll see here, because of how many languages this model was trained on, there aren't even benchmarks that cover 1600. So here's FLIR 81, which I assume is 81 languages. And you see the largest Whisper model's got about 22% word error rate. And here, the biggest of the LLM models has got 5.6. So a very significant improvement across a wide range of languages. And even if you go down to the 300 million parameter model, it's also performing pretty well. I can show you quickly the architecture. It's an encoder with a decoder. This is not unlike Whisper. The encoder is trained on audio, so audio in, trying to predict audio out to get latents out. And that feeds into an autoregressive decoder, which is like an LLM, that will predict the next token. And that also needs to take in what the text embedding is here. I guess, this is autoregressively feeding back and producing the next tokens. Now, there's also support, which is not the case in Whisper, for putting in previous turns, little examples. So you can put in an example of prior audio and text. This is called few shot examples, although they call it zero shot in the paper, which I'm not sure why that is. But if you put in few shot, in principle, it should improve the performance. And it does. They show in the paper improve it for very obscure languages that aren't even covered in this data set. You can generalize to those languages. But I have tried it out. I've tried it out on Irish and I'm not able to get significant improvement. It also doesn't change the capitalization or punctuation. So I decided not to serve it as part of the endpoints here just because I didn't see a significant improvement there. But very nice idea. And I think these few shot ideas are particularly, the theory is really nice for working on multiple languages. Now, a few quick comments on what I would do if I wanted to develop a strong model. This is what we do with customers if they have lower resource languages. Often we would, first of all, think about maybe repairing the capitalization and the punctuation of the model, as I showed. And we would fine tune the model to fix that. So we could either fine tune OmniASR, or we could generate a lot of text from audio. So if you can collect a lot of audio for a language that's lower resource, you could use a model like OmniASR, perhaps with the capitalization corrected, and that can generate a labeled data set, which you could then use to train a smaller model, because the architecture of OmniASR is not that easy to inference, just given it doesn't have broad support for, say, VLLM or all of the libraries that Whisper has got support for. So this is an overview of Omnilingual. I think it's a really nice piece of work. You can see, I'm really optimistic about AI for lower resource languages like Irish, because it just lowers the cost of improving the quality so much. You can get so much labeling done. And I think sometimes you would imagine, well, maybe these languages would get ignored or something like that. And, there can be aspects of that, but because the technology cost is going down, I think it will just make commercial sense for businesses to cover more languages because it's cheaper. And I think we can see that if you look at the number of languages that the big labs cover, it's already quite significant. So that's it for this video. Let me know any questions below. Cheers, folks.